When you use integration to calculate arc length, what you're doing is dividing a length of curve into infinitesimally small sections, figuring the length of each small section, and then adding up all the little lengths. The following figure shows how each section of a curve can be approximated by the hypotenuse of a tiny right triangle. You can imagine that as you zoom in further on a curve, dividing the curve into more and more sections, the minute sections get straighter and straighter, and the hypotenuses of the right triangles better and better approximate the curve. That's why, when this process of adding up smaller and smaller sections is taken to the limit, you get the precise length of the curve. So, all you have to do is to add up all the hypotenuses along the curve between your start and finish points. The length of the legs of each infinitesimal triangle are dx and dy. And thus, the length of the hypotenuse is given by the Pythagorean theorem. Remember that the Pythagorean theorem is the key to the arc length formula. To add up all the hypotenuses from A to B along the curve, you must integrate. But first, you got to tweak this a bit to produce the formula for arc length. First, factor out quantity dx squared under the square root and simplify. Now, you can take the square root of dx squared, that's dx of course, and bring it outside the radical. Now we got the formula. The arc length along a curve of a function from A to B is given the following integral. The expression inside this integral is simply the length of a representative hypotenuse. Try this one. What's the length along y is equal to quantity x minus 1 raised to 3 halves from x is equal to 1 to x is equal to 5? First, take the derivative of your function. Then, plug this into the formula and integrate. Remember that this was obtained as the derivative of the given function. Then, this is the squared of 3 halves. See how this works? It's the guess and check integration technique with the reverse power rule. The 4/9 is the tweak amount you need because of the coefficient 9/4. Then, by performing the indicated operation, the length along y is equal to the quantity of x minus 1 raised to 3 halves from x is equal to 1 to x is equal to 5 is approximately equal to 9.07 units. Now, if you ever find yourself on a road with the shape of y is equal to the quantity of x minus 1 raised to 3 halves and your odometer is broken, you can figure the exact length of your drive.